Now, I'm going to go back to the beginning, so just leave your pencils down and watch. Let's see. All right, let's take, I'm going to say that's 30 degrees, and I'm going to say this is 12. Okay, now, I need to draw a third side to this triangle. And what I have is three possibilities. I have a possibility of 0 triangles, depending on that length, 1 triangle, depending on that length, and 2 triangles, depending on that length. We all remember this? Okay. So, first thing that I do in this question is I find the height. Because why? What does the height tell me? Okay, it doesn't instantly tell me how many triangles, but what does it tell me? Can I have a triangle in the first place? That is the minimum length possible, right? So I drop it down. Now, think of this as a piece of string, okay? And it's dangling from this point right here. This is the shortest distance from that vertex to this point on the other side here, right? That means that that's the shortest possible length that third side can be in order to get a triangle. So let's calculate what it is. So the height, where is this in relation to 30 degrees? Where is this? Hypotenuse. Opposite over hypotenuse again is sine. So the sine of 30, sine 30 equals h over 12. What is the sine of 30 degrees? 1/2. So 1/2 times 12 is 6. See, we just learned something this week. Okay? And that makes it pretty easy, right? So the minimum possible length I can have for my third side is 6. So what happens if that length is less than 6? There'd be 0 triangles. So I'm going to label it like this. A, B, and C. Okay? In order for there to be 0 triangles, my side length for A has to be less than my height. Does that make sense? So this side right here, that side is side A. If the measurement given to me for side A is less than the height, I have 0 triangles because that line won't reach the bottom. So if it was a length of 5, it would only come up to right here. If it was a length of 4, it would only come up to right there. It wouldn't reach the other side, so I have 0 triangles. You okay with this? All right? Okay, now, what happens if A equals H? I have 1 triangle. Because it actually is this length right here. If A equals H, there's only 1 possible triangle. So far, so good. We remember this? All right. So here's where we're going to go from here. So I'm going to work on the 2 triangle part of this. Let's say that A was equal to 10. Okay, so the length given to me is A equals 10. That means it's greater than my height, but smaller than my other side given to me. There's 2 triangles. So let's see how I can possibly get 2 triangles out of this. All right, so here's triangle 1. The first thing I want to do is I want to find out what angle B is. I need to use the law of sines. So the sine of B over 12 is equal to the sine of 30 over 10. Get your calculators out and find out what this is. Again, what do we have to remember when we have an angle? How do I find an angle?
The second function.
Second function, that's right, Jeffrey, did you get it?
36.869.
Perfect.
On the coastline to find the other way.
No.
6.87.
Yeah.
Eight. Okay, say, what is this part of it?
870.
870, thank you. Okay, just a rounding. Jeffrey, is that what you got? If you round it right, correctly?
Yeah.
Okay, all right, what was your question?
Why can't we use the coast swap to find the other side line? Because you're gonna see across the side of the
Okay. All right, the coastline, the law of cosines only works if you have side angle side or side side side. It doesn't work any other way. Okay, so that gives me this right here. So what does that make angle C then? How do I get angle C? Subtract what?
those two angles.
Okay, so 180 minus 66.87. A little louder, Jake. 113.13.
Yeah.
Right? Okay. Now I need to find side C. So I got to use my law of sines again. So side C over the sine of 113.13 is equal to 10, over the sine of 30. Was side C equal? All right, what's the first initial check to make sure that I probably have this right? Is the biggest side and the biggest angle across from each other? Yeah. Okay, so that's the first check. So there's triangle number 1. Okay? Now, with that, okay, how is it that I get a second triangle? Well, if I have a length of 10, it goes out this way. We agree? And if I let it swing back this way, it's also going to go right there as well. I can start it going this way, or I can let it swing and come up to right here. That creates another triangle. So now I want to solve for that other triangle. Okay, so how do I solve for angle B?
Over 12, and sine 30 over 10.
Excuse me.
Or
Okay,
again,
try,
B over 12. And then sine 30 over 10.
all right, so sine B over 12 equals sine 30 over 10. Agreed? What is B? Casey work. What's B?
143.13.
Everybody get 143.13? Dakota, what'd you get?
Yeah, subtract it from
Okay, what did you get? 36.870? Who else got that? What do we have to do now? Okay, we have to find out its supplementary angle. And that's what we worked on for the last 2 days. Remember, there's always 2 angles that will give you the same ratio. So I subtract this value right here, from 180 degrees. So 180 degrees minus my B value gives me this angle right here, which is 143.13. So that is the measure of that angle right there. And that's because the sine of 30 degrees and the sine of 150 are equal. And the sine of 36.870 and the sine of 143.13 are equal. Those ratios are equal for sine if the angles are supplementary, meaning they add to give you 180. Okay? So what's angle C then? 6.870. Okay? That's angle C. Right? And then I gotta find side C. Sine 6.870 equals 10 over sine 30. What does side C equal? 2.392. All right. Okay. I have, I think, about 5 of you. Colby, you've never seen this before? No. Georg, new to you? Yeah.
No, because
You're good? You're good. Carl, have you seen this before? Sandra? Seen it before? Okay. All right. Anybody having difficulty with this today? Okay, so it's a review for most of you. So we'll work through it. This explains everything right here. Okay. So that's what I just did for you before. So again, let me just go back to here. All right. I didn't put it up here. How do I get two triangles? What has to happen?
A has to be greater than H, but less than B.
A has to be greater than H, but less than B. So if H is less than A and A is less than B, I have two triangles. That means when they give you this measurement right here, if it's greater than that value that you solve for first, but less than that, you'll end up with two triangles. Okay? So if this length is given to you and it's less than this, no triangles. If it's equal to it, one triangle. If it's greater than this value here, but less than that, two triangles. And what happens if that value is greater than that value? It can be one, but it won't happen if it'll depend on this guy right here, what that guy is. Because if it's pretty small, then it probably isn't going to happen. Right? Okay? So, you have the rest of today, 2.2. Finish off 2.2, and those of you that can finish 2.2 can go on to 2.3 today. Yes, I'll go through the actual examples with you tomorrow. Okay? All right.